kick ass. So it's always the first step tells you how it will factor, and the second step tells you what you have to add to make it work. So this becomes x minus 3 squared, and what's over here? Negative 4, and now I can do what to both sides? Square root. When I square root, what do I better put here? So if you guys forgot the plus or minus, these die. Yeah, what's the square root of 4? 2. So what's the square root of negative 4? 2i. Because again, just to really play this out, can't I write this like this? That still makes negative 4, yeah? And the square root of 4 is 2, and the square root of negative 1 is by definition I. And then you have one more step. Add 3. So I get x equals 3 plus or minus 2i. Shapow! Whatever you get on part A should be the exact same answer you get on part B, because they both are the same problem. I'm just solving them 2 different ways. Yes?
I can't tell if you marked this wrong or not.
Oh, you're okay. I don't remember what my issue was, but I crossed that. If I don't take points off, you're good.
Okay.
Yeah. So notice what's happening Thursday. Right? So for all of you who are like, man, why can't I have a quiz every day? I'm sorry. So we'll have a quiz Thursday. What's happening next? Is it Thursday? Yeah. Test. So I'm actually going to give you the practice test this Thursday, I think. Just so you have it, you can look at it over the weekend if you want to. And then on the 4th, the day before the test, it'll be review day. I'll have the answer key for the practice test. We won't do anything new on the 4th. We'll just review. That's how every day before the test is going to be. Isn't that crazy? It's crazy. It's almost like you want us to pass. Okay. All right. So you guys can, again, just to say this one more time, really listen to me. When you make corrections, you can go over them with the tutor. You can come to me and say, I'm not turning this in, Jeff. Can you tell me if these look okay? And I'll tell you any that don't look okay. And if I have time, I'll help you with them. Ownership. So I have people turn in quiz corrections and they get 0 points back because they're all still not right. So get help. Get help with it. Get those points back. Yeah, straight. Okay. Does anyone need this? This is the worksheet we've been working on the last couple of days. Anybody still need this one? I'll give myself one. Everybody else got that worksheet? So what we're going to finally do, and when I say we, it's kind of funny. I want you guys to work on the back. And then I'm going to catch up to you when you're done. So, okay. What about this very first problem? How do I test this thing to see if it's a function?
Vertical line.
Vertical line test. So, is this a function? Why?
Passes the vertical line.
Passes vertical line test. Yeah, that's all you got to do. Yeah. Passes the volt. Okay. So what are the domain and range? The domain, of course, is all the what values? X values that have outputs. So what's the lowest for the domain? -8. And the last X value that has an output? 4. The range, you do the exact same thing, but now you just do it for the Y's. What's the lowest output that's possible? -7. What's the highest output? 2. Cool. Yeah. F of -6. Yeah, it's got to be 2 because that's where they put the point. So I think everybody's cool with that. When you first see this question, it might be kind of weird because it didn't give you a function, but it did better. It gave you all the answers. When I say where, that's x values. So where is this increasing? So where did it start to increase? -8, and it stopped increasing at -6. Good. So from -8 to -6 on that interval, it was increasing. What's it doing at -6?
Changing.
So it's resting. Yeah? So if I throw something in the air, it hits the top and it sits there for a millisecond, then it starts to fall again. Not a millisecond. So -8 to -6. So I don't put a bracket there. Where else is it increasing? Starting at what x value is it increasing? From 1 to 4. Where's it decreasing? -6 to 4, and -6 to 1, and I pointed this out, you can see that's what I left out here. So very often you'll see that. So from -6 to 1, it's going down. If this is a profit function, we are sad, and then we're getting a little more happy, but then we break even. Oh shit, well, sometimes it's really good. So what is the output? Where is the input? So what is the local max value? What's the maximum value it hits? 2. Where does it happen? X equal -6. What's the local min value? -7. And where does it happen? X equals 1. Kick ass. Let me stop for a minute. Maybe less than a minute. Okay. So hopefully the first problem was relatively straightforward, right? We've seen enough of these pictures and you can kind of glean stuff from it. What about this thing? Now here's the neat thing about domain. If I give you a function, not a picture. A picture is nice, domain you just see it. What kind of answer would f give me? For any input, can somebody tell me what kind of answer it is? If I put a 3 in there, a 4 in there, what kind of number do we get? Fraction. Kick ass. And what cannot happen in a fraction? What can I not let happen in a fraction, or else things freak out? They make little black holes, they kill people. The bottom can't be 0. Now, I need you guys to really understand what I'm about to say. If I ask you the domain of a function I give you, if you can say in English what the issue is, write that in Mathish, solve, you're done. So you just told me bottom cannot be 0, correct? So let me write that in English, which is my second language. Math is my first. Bottom can't be 0. This is for f. What's the bottom? X plus 5. Can't be 0. How do I solve it? Subtract 5. So x can't be -5. Done. Now, of course, some of you guys realize you can just look at that thing and see, oh, -5 makes the bottom 0. So you can just go straight to here. Beautiful. This one works the same way. What's got to be true about the number that I put inside of a square root? What must the inside be?
Negative.
It can't be negative. So in English, for G, the inside must be greater than or equal to 0. Is that all right? And what is the inside? Subtract 10, divide by 3. I'm pretty sure y'all can do that, so I'm going to just put this down. Subtract 10, divide by 3. So x has to be greater than or equal to -10/3. Can somebody give me a number that's less than -10/3? -5, kick ass. So when I put a -5 in there, you get 3 times -5, -15 plus 10 is -5 squared, and -5 freaks us out, because when I'm talking about functions, unless it states otherwise, I want everything to be real. They have to specifically say, we allow complex numbers to that, right? Okay. What about, is everybody with me so far? So it's kind of nice. If you can say in English what the stupid function needs to be true. Bottom can't be 0. Inside's got to be at least 0, right? And then just translate that to Mathish. You can solve that thing, you're done. What about H? Does H have any issues? It's nice for him, whatever. Yeah, so every polynomial, what's the domain? What can I square and add 1? Any number I can't do that to? Anything. So all real numbers. So H would just be all real. Numbers. Look at me giving us so much room to work with. Now, part B is pretty straightforward, yes? How do I do f of -4? What do I do? Yeah, plug -4 in the appropriate function. So can I just kind of do, what's 4 times -4 is? -1. And then -4 plus 5? 1. So I just get -17. Is that right? -17 over 1. So yeah, definitely let those kind of problems be nice. Did anyone figure out part C? I kind of helped a few people out, but what's the operation between F and G? Division. So really, a way that I can immediately rewrite this is F of 5 divided by G of 5. I want F divided by G evaluated at 5. So the best way to do that is F of 5 divided by G at 5. So this one comes out really kind of beautiful. I love what I've done here. F of 5, can I do this kind of quickly? F of 5 is 20 minus 1 is 19. Divided by 10, is that cool? 19 divided by 10. Divided by, what's G of 5? Yeah, 15 plus 10, 25. Square root of 25 is 5. And how do you divide fractions? So then I get 19/50ths. Is that cool? You guys with me?
You gotta flip it.
Did I not? What did I do? I did flip it.
Did you?
Totally did. So it was a 5, and now it's a 1/5.
Okay.
Yeah.
For some reason I did the opposite.
Oh, okay. Let me stop for a minute. Is that cool? F of 5 is 19/10. Divided by G of 5 is 5. So then you multiply by the reciprocal. Done. Are you guys all right? Again, this is neat. If there's ever a poker tournament and I see you in there, I'm not playing. You guys have this beautiful poker face. Me, I have to wear big ass glasses. Anybody ever watch poker? I'd have to like cover my entire, because my emotions are immediate. I'm like, whoa. Oh. That's why when I play poker, I suck. Yes. Huh? What's the reciprocal of 5? 1/5. So how do I divide fractions? I multiply by the reciprocal of the second dude. Yeah. Did I show you guys why that's true? I thought I did. Side note. Do you know why the shit we do that? Does anyone know why we multiply by the reciprocal? Anybody?
Opposite of division, or the undoing of division.
Yeah. Why? So, real quick, side note. Total side note. So if I had to do 3/2 divided by, doesn't matter, Jeff, 9/4. Don't write this down. Just watch. Total side note. Never do what I'm about to do. I'm about to prove to you why multiplying by the reciprocal works. It's a shortcut. How do I write something divided by something else? Don't I write it as the first dude divided by the second dude? Do you start to see you would never do this shit? Do you want to write a fraction like this? No. What's the best denominator to have? What's the absolute best number to have on the bottom?
1.
Freaking 1. And I can multiply top and bottom of a fraction by whatever the shit I want to except 0, yes? So what would I multiply this by to make it become 1? 4 9ths. So I'll do the same thing on the top. So what's the bottom become? 1. So see how this equals that? This equals that. Shabam! So that's why multiplying by the reciprocal works. Because if you write it in its ultimate gross form, you could do this, and now we make a shortcut out of it. It's just a shortcut. Okay. And some of you guys are like, I didn't need to know that. Well, too bad. Now you know. Coming back to this. So that's all I did there. Just multiply by the reciprocal. By the way, think of it this way. What's 19 being divided by? It's being divided by 10, and it's being divided by 5. So it's being divided by 50 total. Yes? That's another way to kind of look at it. Okay, I like it. You would, Jeff. How do I do part D? What do I have to do first?
H and negative 1.
Yeah, I got to know what the hell h of negative 1 is so I know what the hell to plug into g. So what is h of negative 1? Negative 1 squared plus 1? 2. And then what's g of 2? 6 plus 10, 16 squared of 16 is 4. So almost like I thought ahead. You guys okay? Let this be easy. Let this be easy. All function stuff is, mostly is just substitution, and then finding the domain, it's literally just tell yourself what can't happen or what must happen, and then write what you just said in Mathish. So what about this guy? What the shit? What the shit? Well, all right. How did we do g of 5? Didn't we just plug a 5 in? What about g of 6? Wouldn't you just plug a 6 in for x? So what about g of I don't care? What do you do with I don't care? Plug it in for x. So if I rewrite it, square root of 3 times stuff plus 10. That's what g does, yeah? And what's the stuff? b minus 3. So I get square root of 3b minus 9 plus 10. So I get the square root of 3b plus 1. Sorry. I can simplify the inside. So whatever is inside the function, I just replace x with it. That's all function notation means. Stop for a minute. Okay. So I want you to notice the similarity here. See how I told you what the function I wanted you to plug into G was? Here I reference something. What am I plugging into G? H. And what is H? So now this looks just like part E. What do I do with this? I just plug it in place of X. It's very single-minded. Whatever's in here, shove it into G, right? How does G feel about all this? We don't care. We're even. So then G would be 3 times stuff, and the stuff is x squared plus 1. Do you see how I just took this and I replaced x with it? That's what you always do. That is just what you do. And then I can simplify this a little bit. This will be 3x squared plus 3 plus 10. All right, how you guys doing? Okay, thank you for that. If you're not doing well, let me know. Let me know where I'm losing you. Ask questions. Okay, and then the second E, or yes, I'm sorry.
So you keep the square root, you don't get rid of it or anything?
What would make it cancel?
Squaring.
And am I squaring the square root? No. And in fact, even so, if that wasn't there and that wasn't there, then I could get rid of the square root. But there's all this shit in the way. Yeah, okay. I like it. Hey, Mikey. Now, this guy, let's talk about this guy, because we haven't even talked about that guy. So just leave him alone for a second. We'll come back to him. I'm going to talk about the general idea. So let me ask you this. Let's say that I leave my house and I start to drive. Right, so let's see. 1, 2, 3, 4 minutes. And let's say, 1, 2, 3, 4 miles. So let's say I start driving, and in 4 minutes, I get 3 miles away. Everybody with me? Doesn't matter. This is not a straight. No. So what is that? Can somebody tell me what this means, by the way? So I start driving. This curve going up. What does that mean?
Speed.
That's how fast I'm going. So aren't I speeding up? So if this is how far away I am from home, let me put next to this miles from home. And this is minutes. Chibow! Right? At first I was going kind of slow and then I sped up. Kind of makes sense. I got to get out of my neighborhood. So I don't want to run anybody over. And then I start to hit the freeway. So I get to there. Is everybody with me? Can anyone tell me what my average speed was? Am I going the same speed the whole time? No. But what was my average speed? What's the total distance I went?
3 miles.
Is everybody with that? I went 3 miles in how many minutes? 4 minutes. So my average speed would be 3/4 miles per minute, yes? You guys see that? What did we just do? Didn't we just go, I went 3 up and 4 over? Didn't we just calculate the slope? And remind me, what is slope in general? What over what? Y's over x's, correct? So, and isn't speed miles per, in this case, minute, normally hours, but it's okay. You guys familiar with me? So, speed is the average rate of change of position, and that is the slope of a position graph. So, the slope is the average rate of change, because slope is y divided by x. So if a question says, what's the average rate of change of this function from whatever to whatever, you just find the slope. So let me give you an example closer to what we have on the thing. Actually, exactly like we have on the thing. So if I give you a function, what you got, Jeff? Doesn't matter. X cubed minus 4x, yeah. And I want to know the average rate of change of the function from x equal to 1 to x equal to 3. Shit, don't do that. So I remember, when I see this phrase, average rate of change, I think slope. How do I calculate the slope? What do I need to get the slope? I need 2. What do I need to get? How do I get the slope? I need 2 points. I gave us x values. I didn't complete the point in each case. If I know x is 1,
Plug it in.
plug it in. So what are these points then? 1 comma what? Yeah, 1 minus 4. And 3 comma what? What's 3 cubed? 27 minus 12? 15. Can you find the slope between those two? Shit, yeah. So once you create the points, it's easy. The y2 minus y1 over x2 minus x1, that's easy. How would you make the slope? What would you put on top? 15 minus negative 3. So a lot of people feel like I put a minus already, but it's going to be minus the number, and it's negative, over 3 minus 1. So I'll get 18 over 2, so I'll get 9. So just to show you what the book is going to make this look like, can somebody remind me where 15 came from? Where did 15 come from? Putting 3 into f, right? So what we really just did was f of 3 minus f of 1, y2 minus y1, over x2 minus x1. So in the book, you'll see average rate of change equals, from x equal to x1 to x equal to x2. You'll see f of x2 minus f of x1 over x2 minus x1. That makes it look so complicated, when really it's just make the 2 points, get the slope. That formula just makes it look worse. F of x is a y, so that's y2 minus y1 over x2 minus x1. That's all that shit is. So look back at the problem on the handout. What would you do first? Yeah. So what point do I get from this guy? Negative 2. Well, let's figure it out. So it'll be negative 8 minus 1 is negative 9 over negative 2 plus 5 is I'm sorry, this is too much to try. I'm sorry. So let's figure out, let me do this on the side. F of negative 2 is negative 8 minus 1 over negative 2 plus 5. Right? Aw, poor little 5. That's negative 9. That's 3. What's negative 9 divided by 3? Negative 3. So that's negative 3. So I get the point negative 2, negative 3. Now what's f of 2? That'll be 8 minus 1 is 7 over 2 plus 5 is 7, so I get 1. Dear God, Jeff. So I'm just constructing the points from the inputs they gave me, and then I just have to find a slope. That's it. That's what the phrase average rate of change means slope. That's all it means. So then you just find the slope between those 2 points. Okay, I love you guys. It's almost too good to believe. Some of you guys even look bored. You're like, come on, Jeff, give me something hard. So what's the average rate of change then? Arg. Arc. What's the average rate of change? How do I do this? It'll be on top. What will go on top? 1 minus negative 3 over 2 minus negative 2. 4 over 4? Oh, now that still works. Equals 1. So when you see a question, average rate of change, you just got to find the slope. Make the points, find the slope. You are done. Okay. Maybe. So just to look forward a little bit. Is any questions on that? I know I got a little smushed on the bout. Yes. Where to put you? Here. Yes. So I give you from what to what. I input those two, make 2 points, and then I find the slope. So they gave us a function, and they said, what's the average rate of change from x equal 1 to x equal 3? So I find the points that those relate to, and then I just find the slope. That's all I do. You'll see this formula, but all this formula is get the y, get the other y, get the slope. That's all that formula is. Okay. All right. Yes? Say which one? Up here? Yes. So it was, so how, isn't it y2 minus y1? 15 minus negative 3 is 15 plus 3. Yeah. So be really careful. There's a minus in the formula, and then if your number's negative, they should kill each other. Yeah. Okay. Some of you guys feel like, I already put a negative. Well, I would have put another negative. So you get the right answer. Okay, so coming back to the book. So just so you know where we are, we just did section 3.3, rates of change. The behavior is just the increasing, decreasing, which I already talked to you about, right? Where I know about increase, decrease. So the next thing is composition of functions, but the funny thing is I've been sprinkling that throughout. Composition just means one function is composed of another function. Oh shit, I should probably switch it over. So this is a composition problem. This problem we just did right here. One function is composed of another function. Another way to say composition is just input a function into another one. We've already done that. So let me ask you this. One other thing that's in that section is if I have 2 functions, what do you guys think this problem wants me to do? What does that problem want me to do? You did a harder problem on the handout. Yeah, the way I can immediately rewrite this is f of 1 plus g of 1. It wants the addition of the functions evaluated at 1. So a smart way to do that is evaluate each one at 1 and put them together, right? So this will be 5 plus put a 1 in. Good. -3. So what if I ask you what f minus g of 3 is? What would you do? F of 3 minus g of 3. What if I say f times g of 3? What would you do? F of 3 times g of 3, yeah? That's all. Nothing big. But do you see how this is different from this? What does this say to do? These are different. What does this say to do? Figure out what this is, and then plug it into f, right? This one says multiply the functions at 3. Okay, so let me get the functions at 3 and multiply those numbers together, right? Okay, maybe. Nothing too taxing. Again, it's just getting used to the notation. Why can't they just say multiply them? It's because math is all about the notation. It's all about the shorthand. It's all about the shortcuts we take to say something. We can have an entire paragraph written in one equation. Okay. So, coming back to the book real quick. I'm going to let us out here in a minute. We're going to get into transformations of functions. How much have you guys done, like, take a parabola and move it up, move it over, move it down? You can figure out where the vertex goes. What about take a parabola and flip it? Do the reflection of it? You can't do it really easy. Take this and make it like that. Yes? Does that sound at all familiar? So we're going to talk about what does it look mathematically for me to take a graph and move that thing around. What does the math look like? And that's transformations of functions. 3/6 is sort of a review, but we're also going to graph them. We're going to graph absolute value functions. They look like V's. And then 3/7 is going to be really exciting. For somehow, has anybody ever heard of the Nazca lines down in South America? Very quickly. Nothing to do with math. But it's these lines that were developed way back, like thousands of years ago, and they only make sense if you're way up above them. You can see the image it makes. So there's people that are like UFOs, but then there's speculation. Maybe they had hot air balloon technology. Nobody knows. Somehow Nazca lines that compare it to inverse functions somehow, so we'll find out. I'm going to let us out early. Why not? We deserve it. What the hell? So I'll see you tomorrow. We have a quiz on Thursday, so try to get homework questions ready for this.
Did you check?
Yeah. Alex, right. Here, this will be quick.
Okay.
I got my quiz answer keys. So you have 6. Good. 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 And you had... Okay, I see. Yeah, cool. All right.
So do I just put it in?
Just turn it in. Yep. Thank you. Oh,
How does this work?
all right. Just a second.